Alright, so now let's look into some other examples where we're going to utilize some different form of equality solving tool in order to solve it. This example, we have 0.2x plus 0.9 is equal to 0.3 minus 0.1x. So we always have to keep these equality tools in mind when we're solving an equation and solving for a variable. So usually the first thing we look into is like terms. So we'll analyze that on both sides. On the left hand side we have a variable and a constant, so we can't combine those. And then also on the right hand side we have yet again a constant and a variable, so we can't combine like terms. Now we can begin to just move the variable to one side and then move the constant to one side by applying the adding and subtracting of both sides. But these decimals are really messy. So what I propose is that we're going to multiply the multiplication of both sides. Now, namely, I want to get rid of the decimals in this problem. So what I'm going to do is multiply everything by 10. So we know that multiplying a decimal by a multiple of 10 will move the decimal point value over to the right, dependent on how many zeros there are. So because there's 1 0 in 10, that would mean that we will multiply when we multiply these decimals, it would move the decimal place over by one spot to the right. Okay, so now this is also a really good step because this kind of highlights the distributive law, where we would have to distribute this 10 to each value in this equation. Alright, so I will draw this, I will write this below. So we have 10 gets multiplied to 0.2x plus 10 gets multiplied to 0.9 is equal to 10 times 0.3 minus 10 times 0.1x. Alright, so recall, as I said earlier, multiplying it decimals by a multiple 10 would result in moving the decimal point value to the right depending by how many zeros. So we have 1 0, so that means that this decimal point is just going to move one space over, and as a result we get 2x. The same thing applies over here. We just move it one space over, we get 9 is equal to, we move this one space over, and then we get 3. Then we have minus, we move this guy one step over, and then we just get 1x. Okay, so now from here, we want to get the variable on one side, and then we want to get the constant on over to one side. So I'll begin by moving the variable. Now, when deciding which side you want to move something, my preference is to always move the smaller value over to the larger value, and namely when working with variables. So let's begin by, we want to move this 1x over to the left hand side. So we'll apply the addition of both sides. So we see that this drops out. 2x plus 1x gives us 3x. Now the rest just drops down. Nothing was changed. Now we want to move the constant over to the other side. So now we're going to apply the subtraction of both sides. So you see that the 9's cancel out. Then we have 3 minus 9. That gives us negative 6. Now we're left with a coefficient in front of the variable, so we must apply the division to both sides. So we'll divide over by 3, and we have x is equal to negative 6 over 3, and that reduces to negative 2. Now, I'm not going to go to check this problem. I'll leave that as an exercise for you. Now, when checking this, you can either apply it to the original equation, which is this guy over here inside the brackets, or you can actually apply it to this top one right here. So I will leave that for you to do. And with that, we'll look at another example. But first, I'm going to see they solve this. Okay. Alright, so in our next exercise, it's very similar to what we just did in the first, in the one that we just worked on. But instead, we're going to be dealing with fractions. So we have 1/4 x plus 1 is equal to 1/6 x plus 1/2. So yet again, we could just we first check for like terms. So we have a variable and a constant, and then on the right hand side we have a variable and a constant. So we can't combine anything. So next we look into just solving this equation by using these equality tools. Now, when working with fractions, it can be really difficult. So as the previous problem where I multiplied by 10 the whole equation in order to get rid of the decimals, we want to do something very similar in order to get rid of the fractions. Now, the key to this problem is to look at the denominators of each of these values. So the denominators that we have is 4, 6, and 2. And now we want to find their least common multiple. So we'll begin by multiplying by 1, then by 2, then by 3, and then by 4. And then seeing where they share a multiple. So 4 times 1 gives us 4, 4 times 2 gives us 8, 4 times 3 gives us 12, and then 4 times 4 gives us 16. 6 times 1 gives us 6, 6 times 2 gives us 12, 6 times 3 gives us 18, and 6 times 4 gives us 24. 2 times 1 gives us 2, 2 times 2 gives us 4, 2 times 3 gives us 6, 8, and we haven't found anything. We see that the 8 is common right here, but 12s are common right here. So, and I know that 2 times 6 gives us 12. So we know that also they have 12. So our least common multiple is going to end up being 12. Now the reason why I didn't have any room, but 2 times 6 would give us 12. So with that in mind, what we're going to do is multiply this whole equation by the value 12. Alright, but before, we need to make some room. So yet again, we apply the distributive law, or this will be distributed to each term. So we'll have 12 times 1/4x plus 12 times 1 is equal to 12 times 1/6x plus 12 times 1/2. Now, 12 times, when multiplying these guys, we can express 12 as a fraction, and we can cross cancel. Now, when we're cross canceling, this only works if the cross terms are divisible by a common value. So we notice that 12 and 4 are both divisible by 4, so if I divide 12 by 4, I get 3, and if I divide 4 by 4, I get 1. So now when multiplying fractions, we multiply across. 3 times 1 gives us 3, and 1 times 1 gives us 1. So that's going to give us 3 over 1, which is the same as just 3. 12 times 1 gives us 12. Now, same thing applies in this for this part. We can cross cancel. Both the values are divisible by 6. So if I divide 12 by 6, I get 2. If I divide 6 by 1, 6 by 2, I get 1. Multiplying across, we end up just getting 2 over 1, which is the same as 2, and we get 2x. In the last value, the same thing can apply when we can cross cancel. Both values are divisible by 2, so 12 divided by 2 gives us 6, and 2 divided by 2 gives us 1. Multiplying across, we end up getting 6. Now from here, we want to solve the equation by isolating the variable. So as I stated in the previous example, my preference is to move the smaller variable to whatever side the larger variable is at. So we're going to subtract by 2x to both sides. Begin by that. The 2x cancels here. 3x minus 2x gives us just x plus 12 is equal to 6. Next we want to isolate the variable, so we must move the constant to the other side, so we'll subtract by 12 to both hand sides. And this gives us 6 minus 12 gives us negative 6, and this is our solution. So with that, we just use these 7 equality solving tools in order to solve this equation. And with that, we'll look at the 2 examples that a student had requested. Well, she requested a few more, but I just wanted to solve 2 of them. Alright, and that'll be in the next video.